Hey everyone, and welcome to This Explainer. I'm absolutely thrilled you're joining me today because, well, we're looking at a paradigm shift that's going to fundamentally change how we interact with technology. We're so used to thinking of AI as just a voice in our phones or a text box on our screens, right? Like a purely digital collaborator. But right now, we're crossing a massive threshold. AI is actually evolving from something that just talks and generates text into an intelligence that can physically manipulate the world around us. We're literally moving from dialogue straight to execution. Okay, let's dive into this. Over 70 years ago, the legendary mathematician Alan Turing asked a beautifully simple question. Can machines think? And for decades, that question was treated as, just a philosophical thought experiment, a far-off sci-fi kind of concept. But today, that question really doesn't feel philosophical anymore, does it? It feels incredibly practical. In fact, if we're talking about the digital realm, we've essentially already answered it.
Just look at how deeply AI is embedded in our daily lives right now. We've completely mastered what we call the symbolic world, the world of text, data, and code. Millions of us start our day by asking language models to draft our emails. AI is out there writing poetry, generating complex software, summarizing medical documents for doctors, and even helping lawyers vet dense contracts. And what's really fascinating here is the data from Anthropic's research. They actually found that AI is acting more as a rapid collaborator. It's absorbing specific parts of our workflows to extend what we humans can do, rather than just outright replacing jobs. So yeah, we've pretty much conquered the symbolic world.
Now, what's really interesting about this slide is the stark contrast we've got to highlight here. Mastering language is absolutely not the same thing as mastering the physical world. Not even close. Language is governed by neat, predictable rules, syntax, and digital data. But the physical world? The physical world is alien and chaotic to a computer. It has gravity, it has unpredictable terrain, it has heavy, dangerous objects that can fall, break, or cause serious injury. So while AI has become incredibly fluent in words, historically, it's been remarkably clumsy in reality.
Section 1. The Physical AI Frontier.
So, researchers and investors globally are waking up to a massive realization. The next true frontier of intelligence isn't linguistic at all, it's physical. And to prove that this isn't just some distant, futuristic vision, let's look at what embodied machines are doing right now. The leap from the lab to reality is happening at breakneck speed. Recently, we actually saw humanoid robots performing kung fu routines to celebrate the Lunar New Year. We have robots successfully navigating the grueling terrain of a half marathon. And in places you'd literally least expect, like ancient Roman ruins, robotic systems are executing delicate, highly complex safety inspections. This is physical intelligence in action.
Let's demystify this a bit and look at some specific, real-world applications. Take Boston Dynamics Spot, for example, which has the form factor of a robot dog. It's actively deployed in industrial environments right now, inspecting infrastructure and navigating highly dangerous terrain to support human operators. Then you've got Tesla's Optimus, which is a humanoid designed specifically to enter warehouses and factories. Its whole job is to augment the human workforce by taking on those physically demanding, repetitive, and injury-prone tasks like moving heavy containers across massive logistics centers. These machines are stepping right into the real economy alongside us.
Section 2. Reimagining robot training. But wait, how did we get here so fast? Because for decades, robotics was incredibly slow-moving. Getting a robot to just pick up a single cup could take years of programming. The contrast here to the new way is staggering. The old way of building robots required years of painstaking manual engineering. Every single behavioral rule, every motor movement had to be handcrafted by an engineer. And if the robot encountered an edge case, boom, it failed. But the new way completely flips the script. Instead of manual rules, we're using massive data sets, reinforcement learning, and advanced simulation environments. Think of it like a digital matrix, where robots can practice millions of times before they ever step foot in reality.
Let's move to the next point and see how this builds, because the pipeline for this digital-to-real transfer is just fascinating. First, engineers create thousands of virtual, highly realistic scenarios. Second, the AI agents driving the robots test and learn in these simulation environments, failing and succeeding at absolute light speed. And finally, once the system has mastered the physics virtually, it gets deployed directly to the physical robot in the real world. This massive breakthrough means building robotic systems is now dramatically faster and cheaper. We've essentially bypassed the old hardware manufacturing bottlenecks that used to choke the whole industry.
Section 3. The Hardware Bottleneck.
Now, if manufacturing and training aren't the primary limits anymore, what exactly is holding us back from a fully automated physical world? Well, we've uncovered a hidden hurdle. To understand this, we have to look at a concept discussed by Yann LeCun, the founder of Advanced Machine Intelligence, during a really fascinating fireside chat at AI House Davos. He highlighted a profound biological anchor to our current hardware problem: the incredible gap between biological efficiency and silicon efficiency.
And this brilliantly illustrates the core of what LeCun was talking about. It really comes down to this. In our biological brains, memory and processing are perfectly unified. They exist together in every single physical synapse and neuron. It is just incredibly efficient. But in artificial silicon networks, it's completely separated. The exact same hardware has to be repurposed continuously, which means data must be constantly shuttled back and forth between memory chips and processing units. And that constant movement of data drains a massive, almost unsustainable amount of energy.
So the crucial point is this: we can't just scale our way out of this problem using brute force. Throwing more and more advanced GPUs at the problem is actually starting to cause diminishing returns. Why? Because the tech industry is quite literally hitting the physical limits of data movement. Our current manufacturing capabilities simply cannot dedicate one single physical device to every single artificial neuron. We are essentially hitting a wall of physics.
And this limitation translates directly into the physical body of the robot itself. The constraints have totally shifted away from digital intelligence and software limits, going straight into the raw physics of the machine. We're now battling battery capacity limits. We're fighting charging cycle constraints. We're struggling with power density, which is basically how much computational power and physical strength a robot can exert before its battery is completely drained. So the mind of the robot is ready, but the body is super power hungry.
Section 4. A Physical AI Future.
But despite these immense hardware challenges, the momentum is absolutely unstoppable. Researchers are actively bridging the gap right now, literally dragging AI out of the research lab and planting it firmly into the real physical economy. One of the most exciting ways they're doing this is through spatial models. Instead of just seeing flat pixels, these models allow AI to build consistent, rich, 3D representations of their environments directly from visual data. This lets robots deeply reason about objects, understand movement, and predict physical interactions. Essentially, we're giving machines a human-like spatial intuition. AI's ultimate ambition is clearly no longer just words. It is undeniably, increasingly physical.
Which leaves us with this final provocative thought. As these spatial models deepen and humanoid systems evolve past their power limits, embodied intelligence is going to scale. So what happens to our physical spaces? What do our factories, our cities, and our warehouses look like when they're entirely reimagined, not for human limitations, but for the capabilities of embodied intelligence? AI's next evolutionary leap isn't happening on a screen in your pocket. It's happening in the physical space right beside you. Thank you so much for joining me in this explainer. Keep learning, and I'll see you in the next one.